And today we're going to talk about 5.2. We're going to do proving trig identities. Okay. So usually when I start out with this, I usually say, okay, so it's not necessarily the mechanics, it's the direction that is important. Okay, so the why we are doing things is important. Okay, but in this case, I would say not only is the why important, mechanics are important too, because you are not used to dealing with these type of things. You are not used to manipulating, okay, trigs to prove an identity. Okay. So as a dry run or kind of a things to come, they want us to do example number 1, which is really not a trig identity, obviously, has nothing to do with a trig, but has more to do with how you go about doing a proof. How do you prove something? Okay, so the question is, do we want to prove that this is equal to 2? Okay, so we're trying to prove this. Okay, so usually in a proof, you start from the left-hand side, manipulate it, kind of massage it to get the right-hand side. And that's what you're trying to do. Okay? So in this one, how would you go about doing that? How would you go from the left side to get 2?
Factor.
Okay, so you'd factor for the top here, right? Because x is going to be x minus 1, x plus 1, and then you would go x minus 1 minus, and over here you get x minus 1, x plus 1, you get x plus 1. And now you're going to go ahead and do, well, this and this cancel out as long as x is not equal to 1, right? So you can't do it. You do this as long as x is not equal to negative 1. And you're going to end up with x plus 1, negative x minus 1, x minus x cancels out, 1 minus minus 1. Ding, 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 we have a winner. Okay?
That was difficult, Mr. O.
So, not really much going on here, okay? As long as you're able to factor it out, then it's kind of smooth sailing from here to here, because you are very used to all of the methods that we used here. Okay, this is stuff that you've been doing since algebra 1, algebra 2, and now in here. Okay, so you've been doing this for quite a while, so it's not that big of a deal. Let's go ahead and flip the page. Let's go to example number 2. So in example number 2, now we're going to use the trig identities, kind of trying to use the same methodology or same kind of strategy that we just used. Okay, and we are going to prove the identity that tan plus cotan plus cotangent x is going to be equal to secant x cosecant x. Okay, so what is your immediate thought when you look at this?
It's difficult.
Okay, it's difficult. Why is it difficult?
It's not numbers.
No numbers, okay. What else? Even within trig identities, you have some odd things going on here, right? You get like cotangent, secant, really? Cosecant? Right, just give me sines, cosines, and tangent, right?
Yep.
Okay, so this is going to be one of the main themes, okay? When in doubt, if you don't see any immediate way to make headway, change the tangents, cotangents, everything into sines and cosines. Everything into sines and cosines. Okay, so that's a fallback strategy for you. Okay? So in this case, let's just go straight into that. Let's go straight into that. Let's go ahead and go into, we're going to change this all to sines and cosines. Okay, so I have tangent x is sine x divided by cosine x. And I have cotangent x is the reciprocal of that. So it's going to be cosine x over sine x. Okay. Okay, I can kind of take a deep breath because I got rid of cotangent. Don't like cotangent. something I'm not used to, so I don't want to deal with it. Okay, so now I'm sines and cosines, so at least I'm more familiar with these guys. So now let's go ahead and combine denominator. So it'd be sine x times sine x, so it's sine squared x. On this side, I have to have cosine squared x. Oh, hey, I got a winner again. I know this. 90% of the time, this is what we're going to use. Remember we said this? So this is 1. Let's have 1 cosine x sine x. So now I'm really kind of lean now, okay? Now lean looking. So let's look at the end result. What am I supposed to get? I'm supposed to get secant x and cosecant x, right? Well, isn't this secant x? And this is cosecant x, right? So this basically is secant x times cosecant x. I'm done. Okay. Again, you started with something that, I mean, this equal to that is not intuitive at all, right? There's no connect, doesn't look like there's much connection there. So I just go ahead and change everything to sines and cosines. Okay, and I just work my way through. Example number 2, so let's go to example number 3. Example number 3 is the same thing, except that they feel that the answer is so weird, they actually give you a multiple choice answer. It's either going to be A or B. Which one is it going to be? Okay. So, go to example number 3. Example number 3. And I'm going to have secant x minus 1, secant x plus 1. Is it minus? Plus. Okay. Plus. Okay. And this is either going to be A or 1, I guess, 2 cotangent x, cosecant x, or 1 over secant x. Okay, so let's find out. So when you look at this, what are you thinking? What's the first step you think we should do? Should we at least try to, well, you can't just flip it because it's not, there's no equal sign here, right? Because there's nothing to flip over on this side. You can't flip it, right? So I have secant x minus 1 and secant x plus 1, right? So it seems as though I can kind of try to manipulate this to get this times this. And then I could do something with that because I remember one of the ways to manipulate the sine squared plus cosine sine x squared plus cosine x squared is equal to 1, right? Involved secant x squared somewhere in there. There was one that did that, right? So actually, I can actually try that out, and I can I can say that. Well, I know this is true. Divide everything by cosine x squared. This becomes tangent x squared. This guy is 1. Secant x squared. If I move the 1 over, I get that. So somehow, if I get this, I can use this, right? So let's see what happens. So I'm going to go ahead and combine the denominators because that is the easiest way to get this guy. So it's going to be secant x plus 1 plus secant x minus 1. These guys cancel out. This guy is this guy, which is this guy. So on top, I have 2 secant x. On the bottom, I have tangent squared x. Everybody see that? Okay, everybody follow that? So again, I have tangents and I have secants. So I'm not sure what's going on. So let's go ahead and change them all to sines and cosines. Okay, so I have 2, This is 1 over cosine x. This guy is sine squared x over cosine squared x. Going to multiply top and bottom by cosine squared x, cosine squared x, cosine squared x. Then this guy and this guy cancels out. This guy and one of them cancel out. So I'm going to end up with 2 times cosine x. And the bottom I have sine squared x. So I can go ahead and rewrite this in this fashion, where this guy is my cotangent. This guy is my, what, cosecant, right? Oh, so that would be number 1, right? So it's going to be 2 times, this guy is cotangent x. This guy was cosecant x. And voila, I get the result is number 1. Okay. Again, it's not necessarily the mechanics, it is also the reason why we are doing things. Okay. The reason why we combine this is to kind of artificially create this to use this. Okay. Okay, so that's that. Let's do one more. Let's do example number 4, then we'll take a break. So if you're asking yourself in the back of your mind, is he really going to ask this question in the test? I can remove any doubt and tell you, yes, these type of things will be on the test. And you'll be required to be able to do step by step, show me what you're doing to prove identities. Okay. Example number 4. Example number 4, cosine t over 1 minus sine t is equal to 1 plus sine t and cosine t over cosine. So this is kind of weird. All right, look at what we got. I have this guy kind of turned into this guy, and all of a sudden this guy showed up from nowhere, right? From here to here. I don't know what's going on. But if I get this on the top, what if I multiply this guy by that guy and this guy by that guy? Right? Because I'm multiplying on the top, I have to multiply on the bottom, right? If I get 1 plus sine t times 1 minus sine t, what do I get? I get 1 minus sine squared t, right? Which is really 1 minus sine squared t is equal to cosine squared t, correct? So I move this over as sine squared plus cosine squared is equal to 1, right? So that's really promising because not only do I create this guy on top, but this guy now, if I have cosine squared on the bottom, would cancel this out and I'd have 1 on the bottom. So things are looking pretty promising here. Okay, so this is how you come to realize that I have to multiply the top and bottom by 1 plus sine t. Right? So I'm going to get 1 plus sine t here. I'm going to multiply this guy by 1 plus sine t. Again, figuring this out is the hard part, right? Figuring out that you have to multiply top and bottom by this. So once I do that, I get cosine t, 1 plus sine t. Then over here on the bottom, I get 1 minus sine squared t, which as advertised is this guy. So So I get cosine t, 1 plus sine t, cosine squared t. This guy cancels out with one of them. And then ding, 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 I have the winner. What I was looking to get. Again, figuring this out is the hard part. But as of yet, since you guys are still not used to manipulating these things, these steps are also, you have to go kind of slow instead of going trying to blow by it. Okay. All right, we'll stop right here for the first part. And we'll come back and finish it up.